Hi, my name is Suraj Matthew Thomas, and this is my midterm submission for the HD task for modern data science. So there is a HD task, question number 2 for the midterm assessment, which requires me to explain what I've done for question 2. So let me go ahead and share my screen, and we'll go through the question and the code one by one. Okay. So I think we are just sharing the screen. So the question that is attempted is version 1 of question 2, which is to see whether a triangle can be formed. So the objective is to write a Python code to check whether, given the sides of a triangle, given the three sides, whether the three sides would actually form a triangle. And if it forms a triangle, what is the type of triangle that is formed? Whether the triangle formed is a right angle triangle, or the triangle formed is an isosceles triangle. So the reason why version 1 was selected is because there was a question in the first part, 1.7, which tells us to find out um, based on the student ID. It gives us that the solution that you get out of that would dictate whether you perform version 1 or version 2. So let me go ahead and open the Google Colab notebook where I have done the work. So let's go here. I think it's connected already. Yeah. So let's go to question 1.7 and see. So the 1.7 is basically to find out whether the input that is given. So my student ID, the numeric values is 22, 350, 9398. So if it comes as an odd number, so I would have to perform version 1. And if it comes as an even number, I should have performed version 2 of the question number 2. So basically, I have defined two functions here. One is the sum of the digits, and the other is to check the student ID. So the student ID function has an attribute which tells me to give the parameter as the student ID, the numeric value alone, and that is what I'm calling over here. So once this particular function is called with the student ID, what it is going to call is the other function that is going to sum up the digits of my student ID over here. I've used the while loop over here where it's going to iterate each number and it's going to find the sum. And I'm going to print out the sum over here. So the sum that has been printed out is 41, which is an odd number. So if it is an odd number, I have to tackle version 1 of the question number 2 in the HD task. So let me go ahead and run this. I've provided the same thing. I've printed out the number, the sum of the digits that is returned from this particular function. So that's why you see 41 over here. And then it is checking with the modulo function, whether it's an even or an odd number. And if it's an even number, it's going to print out version 2. And if it's an odd number, it's going to print out version 1. That is why the if else statement is there. So let's go ahead and run this. So when this is run, when this particular ID is given, it's going to call this check student ID function, which in turn is going to call the sum of digits function, which is going to run iterate over this using the while loop 2 plus 2 plus 3 plus 5 plus 0 plus 9 plus 3 plus 9 plus 8. It's going to do that, and then it's going to return the value. Right. So now this is the reason why I have chosen version 1. So let's go ahead to the HD task. So the HD task, like I said before, is to find the formation of a triangle. If the sides that are given, there are three lists that are given, list 1, list 2, and list 3, which contains, each of the lists contains 3 elements, and the 3 elements represents the 3 sides of a shape. Okay, so we have to find out whether it would form a triangle or not. So there are two methods that I've used, two approaches, the way in which that I've used. One is just a single function. And in that single function, what it is going to check is first if it is going to form a triangle. Okay. If it forms a triangle, then I would check what is the type of triangle it is forming, whether it is a right triangle or an isosceles triangle. If it does not form a triangle, I'm not going to check the type at all because there is no point in checking the type because it does not form a triangle. So the objective of that. So let's go through the first approach step by step. So the function has been defined. That is your your check define the check triangle formation, right? So just define that. So what is happening is first I'm going to input A, B, and C. So those are the parameters that are going to get passed when I call this function. So the A, B, and C can be attributed to the three elements in a particular list. So I'm going to call this function individually 3 times. So once the function is called with the values A, B, and C, what it is going to check is the normal formation of a triangle formula, whether the two sides are the sum of the two sides should be greater than the third side. So it is going to check A plus B is greater than C, and A plus C is greater than B, and C plus B is greater than A. Only if these three conditions are satisfied can I form a triangle. So I'm just putting an if else, and I'm printing a statement saying that a triangle can be formed, a triangle cannot, a triangle can be formed, or coming to the else part over here, a triangle cannot be formed. Okay, if this condition is going to pass, it goes inside. If it is going to fail, it comes out and goes to the else loop where it cannot be formed. Now, if a triangle can be formed, right, it's going to print this statement, and then it's going to check the type of triangle that is going to be formed. So the first, I'm going to check whether a right angle triangle can be formed. Okay, so the right angle triangle formation is nothing but the Pythagoras theorem. Okay, so a squared plus b squared, it should be equal to the hypotenuse. Okay, so if it is going to be equal, then you get a right angle triangle. Else you are printing that the right angle triangle cannot be formed. Now, either ways, okay, you're going to get a statement if else. Then again, a nested statement is going to come in to find out whether an isosceles triangle can be formed. Okay, so an isosceles triangle is two sides of a triangle should be equal. Okay, any two sides of the triangle is going to be, should be equal. That's why we use the or statement, and we are going to check the logical or statement, and we are going to check each of the sides. A is equal to B, A is equal to C, or B is equal to C. So if any one of this condition is satisfied, you're going to get it's an isosceles triangle. If it is not satisfied, you're going to come out and it says that the triangle is not going to be satisfied. I mean, the isosceles triangle cannot be formed. So this is one particular function, one single function where I am giving the list of values. And once the list of values goes in, first it'll check if a triangle can be formed. If it can be formed, then it goes into the other if statement saying what is the type of triangle, whether a right angle triangle or an isosceles triangle can be formed. And it comes out. If it cannot be formed from the main loop itself, it comes out saying that a triangle cannot be formed. So let's go ahead and check this. Okay, so we have run this particular function. Okay, we have not got any errors. And then we are calling each one separately, the three lists, 1, 3, 5, 12, 35, 37, 2, 2, 2.8, and we are calling this function. So when you call this function, the output you get is first one, a triangle can be formed with 1, 3, 5. Okay, a triangle cannot be formed with 1, 3, 5. Okay, so it goes straight away to this else loop, it doesn't check. The second one is second list I'm run. You can second list I'm passing the elements that I'm passing. You can see a triangle can be formed. So when a triangle can be formed, it goes inside and check what type of triangle can be formed. So over here it says that a right angle triangle can be formed with 12, 35, and 37, right? But an isosceles triangle cannot be formed over here. Now, if I go in and check this one, 2, 2, 2, and 2.8, it says a triangle can be formed. But here, this time, a right angle triangle cannot be formed with this, but an isosceles triangle can be formed with this particular list of elements. right? So this is the first method that I have used. Now, okay, the second method is actually individually defining functions, right? So this is, this is a one way that you can get to know everything. But here, individually, if you want to define functions, so individually, the first function is to check only if the triangle can be formed. Then there is a second function that is there, whether a right angle triangle can be formed. And third function, whether an isosceles triangle can be formed. So literally, the second method is splitting each of these conditions, these nested if that is given as one go, which is logically flowing. A triangle can be formed, then what is the type of triangle can be formed? A triangle cannot be formed, there's no point in checking whether a right angle triangle or a isosceles triangle can be formed or not, because a triangle cannot be formed in the first place, right? So now going to this, so individually we are defining, it's just splitting up this and then individually calling the functions to know whether a triangle can be formed, a right angle triangle and an isosceles triangle. Now there's another method that I've used, the third method, okay? The third method is nothing but using the inheritance concept for the object-oriented programming. So you're defining the class as a triangle, and then you're checking and you're defining different classes, which is the check, which can be triangle, right triangle, iso triangle. So these are the subclasses of the main class triangle. So in this method, I'm going to pass. So what each one is that you can individually call these classes. Okay, if it doesn't, it then goes and checks the main class as well. So we are using the class and subclass class and subclass methodology to define this method. So you go ahead and check. So if you check with this, you can check whether a triangle can be formed. If you check the right class, okay, the right class, which is again internally calling the main class, you can check whether a right triangle can be formed. ISO is to check whether an isosceles triangle can be formed. So similarly, it is called 3 times for this 3 lists. So this is the class method. I mean, the class and the subclass approach of doing this particular thing, right? So again, the method 4 is similar to that. But here what we are doing is, instead of individually calling them, okay, so what we are doing is we are mentioning this, the same class and subclass method only. Okay, but here what we are doing is we are using a for loop wherein we go. So let's check this method out, right? So we are just putting formation, whether a triangle can be formed, that's a particular class. Right try is a particular class, whether it can be formed. Iso try is to see whether an isosceles triangle, the above for the right angle triangle. So these are the 3 elements, and I'm going to call these 3 elements in a for loop, and I'm going to call the member.tell. So what happens over here is, so initialize triangle formation, triangle cannot be formed. Here again, it says that initialize triangle formation. It is calling the init method again. So right angle triangle cannot be formed. Isosceles triangle can be formed. So the first approach was you need not have checked this at all, because the triangle cannot be formed. But now when we are defining it as a class and subclass, and we are iterating through it, it is flowing through the entire formation. So again here, the different through a for loop, the different sets, that is the formation, right triangle, isosceles triangle, each of the classes being called with its respective list or elements as its parameters to check whether a triangle can be formed or triangle cannot be formed. So yeah, so that's the 4 approaches that I have taken, the 4 methods that I've taken for doing this particular problem to check whether a triangle can be formed or not. Okay, so the next part is 2.2, where we need to use a particular formula to find the area of a particular triangle, and we need to define a function in Python for doing that, right? So we are going to use the Heron's area calculation. So here again, method 1, two different functions have been defined. One is the Heron's calculation. The Heron's calculation is nothing but this particular formula where we are not importing any library. We are just doing the normal mathematical formula calculation where Heron's formula is, the square root of S into S minus A into S minus B into S minus C, where S is equal to A plus B plus C divided by 2. So we have defined that, okay? And we are returning this particular formula. And the square root is defined by to the power of 0 0.5, 0.5, okay, which is 1 by 2. Okay, and then we are defining the find area function. So find area function again has 3 elements, A, B, and C. And area, we are calling this Heron's area calculation function. So this particular, when we call this particular function find area and give the particular list of elements, it is going to again in turn call another function, which is a Heron's calculation, the function to calculate based on the formula that has been derived. So let's go ahead and run this. Okay, so I've given these two lists. Okay, these two lists, because only in these two lists a triangle can be formed. The 135 triangle could not be formed, so we have not used that. So now find area of 12, 35, 37, where a right angle triangle can be formed, and 2.8 is where we've seen above that an isosceles triangle can be formed. So we have given that, and you can see that the area of the triangle with sides is given as the follows: 210 and 2 respectively. Okay, so that is method 1. Method 2 is similar, but here it's only one particular function, okay, where we have imported the math library. So instead of formula, the only thing is it's very simple. Instead of this, we have just invoked the math.sqrt. Okay, that's pretty much it. So sqrt is going to particularly, invoke, it's a square root method that is written inside the math library. So we can invoke this instead of giving that as star 0.5 and calculate the square root. So and individually we need to call that. So this is 2.0 has been rounded off. Here the raw value is 1.999 and here the area is 210. So we are pretty much getting the same results over here, if you see. Yeah. So this is my explanation for the HT task, which is version 1 of question 2, where we had to find whether the given sides can form a triangle, what is the type of the triangle that can be formed, if a triangle can be formed. And then the second part is to find the area of a particular triangle given the Heron's formula, right? So that's my explanation of this task. So I'll stop sharing. Thank you for your time.